Hello everyone, today I'm going to show you my research on the strongest electromagnet design. The hypothesis of this research is the strength of the electromagnet is directly proportional to the charge and the number of coils around the conductor. So let's begin. The materials used in this experiment are 1.5V battery, a toggle switch, copper coil, wires, and paper clips. This experiment contains of 5 coils around the conductor, 1 battery, and now let's turn on the toggle switch and test how many paper clips can the electromagnet attract. It looks like the electromagnet doesn't have enough power to attract the paper clips. This experiment contains of the same number of coils around the conductor, but I've increased the amount of batteries to see if the electromagnet can attract paper clips. So let's turn on the toggle switch and test. Oh, it looks like the batteries do affect the electromagnet and it can attract paper clips. Let me just write that down. This experiment contains of the same number of coils around the conductor, but I've increased 1 more battery just to see if the electromagnet can really attract paper clips. So let's turn on the toggle switch and test. Oh, it really looks like that increasing the batteries do really impact the strength of the electromagnet. Let me just write that down. Now let's do another experiment with increasing the number of coils. So here I'm taking a solenoid with almost 100 coils and I only have 1 battery. So now we're going to test if increasing the coils really impact the strength of the electromagnet and how many paper clips it can attract. Let's turn on the toggle switch and test. It does impact it. The number of coils, increasing it, impact the paper clips because a solenoid, in the first try, it got 2 paper clips. So let me just read that out. In another experiment, I'm keeping the same number of coils around the conductor, but I've increased 1 more battery just to see if increasing the battery affects the strength of the electromagnet and if it can attract more paper clips. So let's turn on the switch and see. It does impact the strength of the electromagnet. As you can see, these are a lot of paper clips, and increasing the battery really helps, and also increasing the number of coils around the conductor helps attract. So this experiment explains increasing the number of coils around the conductor and increasing more batteries impacts the strength of the electromagnet, and it makes the electromagnet attract more paper clips. In another experiment, we will find out the north and the south pole of an electromagnet. To do that, we follow the thumb rule. The thumb points to the charge of electromagnet and your fingers fold in the direction of the magnetic field around the electromagnet. In this experiment, I will also use a permanent magnet which shows the blue as the south pole and red as the north pole. So let's begin. So here I have a circuit in which the charge is in an anti-clockwise direction and the magnetic field is in a clockwise direction. So let's just see what are the poles of the electromagnet. It looks like that this pole is the South Pole and this is the North Pole. So let me just change the directions. So now I've changed the direction of the circuit. Now the direction of the charge is in a clockwise direction, and the direction of the magnetic field is in an anti-clockwise direction. So now let's just see if the poles attract or repel. So now the poles are not attracting each other. So that means I have changed the direction of the electromagnet and they are repelling. Because the magnets are repelling, this is the North Pole and this is the South Pole.